This is the second video dealing with mid-segments and shapes. The first video dealt with mid-segments and trapezoids, and now we're going to take it a step further, okay? So you can see here, if I take a trapezoid like this, and I go ahead and extend the legs, so here are the two parallel bases, right? If I extend those other legs out, eventually they'll come to a point. And so really I can treat a trapezoid like a triangle, okay? They're the same thing, just I went a little bit farther. So if I want to find the length of the mid-segment, this red line here, you'll recall that what I was supposed to do is average the 19, one of the bases, with the average of the other length. Well, it turns out then, this is like having the parallel line up here, okay? If I average the length here and the 19, I would get the red line. Well, this is just a measurement of 0, right? It has no length. So all we have to do is take 19 and 0, add them up and divide by 2, and I have the length of the red line. You'll also notice, by the way, for a triangle, that means that it's always half of the base, right? If this is 19, I'll always end up with 19 over 2, or 9.5, for the measurement of the midsegment. So it actually turns out to be pretty easy. You only have to take half of the base, okay? That also means, by the way, you'll notice, okay, minus 9.5 gives me a 0, plus 9.5 gives me 19, right? Or, even better, you might notice that if I just say, hey, I'm going to take the midsegment and I multiply by 2, I get the 19, right? So we might be able to work backwards. You can see that's probably coming here in the future. So here we go. Let's find x. Well, I have a base, notice, midsegment, midsegment. So how long is x? Well, what's the average of 35 and 0? That's the same thing as saying what's half of 35. X is 17.5, or we might leave it as a fraction, 35 over 2. Pretty simple, right? We might be asking to work backwards. Notice, first things first, that's a midsegment. Here's a midsegment. That means 13 is the average of x and 0. Or we might say that if I double the 13, I'll be out to the x. That's going to be 26 units in length. Because if I take 26 plus 0, that's 26, divide it by 2, that's 13. I might also look at it this way. Subtract 13 to get to 0, add 13 to get it to 26. See, there's a lot of different ways to visualize this, right? And I don't want you to be stuck on one way. I want you to be able to look at it from multiple viewpoints and use whatever's easiest. To be honest, we just need you to be able to solve for x. You know that. More problems, okay? How about this one? Solve for the variable. In this case, it's n, right? And so if I look, I see that, hey, look, halfway, that's a midpoint. Halfway, that's a midpoint. That means this is the midsegment, right? So 74 and 0 average out to be what? Well, what's half of 74? If I divide 74 by 2, I know that this should be 37 units in length. So now it's just a matter of solving for n, one extra step, right? Subtract the 5 from both sides. That means 4n is equal to 32. Divide out the 4, n must be 8. Does that problem make sense? Okay, how about on this one? I look over here and I say, all right, this averaged with a 0 equals 5x. Now this one's a little bit tougher, isn't it? So here's what I know. This is a length of 0, right? If I take 8x plus 10 and I add 0 to it, I add the two bases, 8x plus 10 and 0, add them up and divide by 2 to find their average. The average should be 5x. See, here's where knowing the formula comes in handy, because there's really not going to be a better way to solve it. Well, step 1, let's double both sides. The 2's go away on the left, so I leaves me just the 8x plus 10. And on the right, I had 5 x's, but now I doubled the number of x's that I had. I'm up to 10 x's. I need to combine like terms. Let's subtract 8x from both sides. So 10 is equal to 2x. Divide out with the 2, and x must be equal to 5. We can go back and check and make sure it makes sense. 8 times 5 is 40, and 40 plus 10 would be 50. 5 times 5 is 25. Yep, now look at that. 50, 25, 0. That's halfway between 50 and 0, just like we expected, right? Easy to check our answers. A couple other things to know before we end, okay? Since the midsegment is parallel to the base, these two are, and because its endpoints and the midpoints of the sides, it makes two similar shapes. In other words, I can say that ABCF is similar to ABDE. The little shape and the big shape are proportional to each other. That's pretty convenient, right? I also know that for triangles, I have a little triangle embedded inside of a big triangle here, and once again, LNP and LNO are similar, right? So I know that I can do like proportion problems. I can do all the stuff we did from similarity in the previous unit. One thing to keep in mind. It also means this. Since I have parallel lines, just like I could do this, right? In previous units we said, hey, if I got parallel lines, that if this is 60 degrees, that I can transfer that up and make this 60 degrees. Well, guess what? I can transfer E up to F because these lines are parallel. I can do the same thing here. I'm not saying that these are the same over here for across the shape, but I'm saying I can transfer upward. And I can do the same thing with triangles over here on the right. Okay? So that's another nice thing that we might be able to use to solve for something. I can say, hey, listen, this is 40 degrees. What's that? Well, you know that that's now 40, right? Just to throw out a number. So here we go. Let's solve for this thing, and this is our last example, and we're done for the day. And you'll be able to do all the homework problems we need to be able to do. First things first, what is angle MLN? Well, if I go from M down to L and out to N, you know that I'm asking, what's this? Well, I know that these two lines are parallel. That makes 63, and this angle corresponding angles. This has got to be 63 degrees. Okay, step 2, what's angle M? That would be this thing here. Well, the problem with this is that in order to solve for this M, I need to first know, like maybe these three angles add up to 180. Can I figure out this one? Well, luckily I can, because 138 and this add up to 180, right? So if I take 180 minus 138, I know that this is 42 degrees. And then I know that 63 and 42 and angle M add up to 180 because they're inside of a triangle. So 63 plus 42 is 105. And I take that and subtract it from 180, and I know that M is equal to 75 degrees. Okay, next step. What is angle M out to N over to L? Okay, that's convenient. It's 42 degrees. We already did that. What is angle NLK? That would be N over to L down to K. Easiest way is I know that 63 and this angle add up to 180. So I take 180 minus 63 and I get 117 degrees. What's angle O? Well, this is interesting. Here's two different approaches. Approach number one, I say, well, I have a quadrilateral here, four-sided shape. 4 minus 2 is 2 times 180 is 360 degrees. Four-sided shapes have angles that add up to 360. There's one approach. Or I could say, look at the big triangle here. 63 and 75 and angle O add up to 180. Hey, you know what? That's going to give you the same answer. So it doesn't matter which approach you take. I'm going to do the big triangle. If I do that, and I use that to solve for angle O, 63 and 75 is 138. 180 minus that is 42 degrees. Oh yeah, you know what? Do you see it now? Corresponding angles. Didn't even look at that. I didn't even see that. And that's my fault. Okay, a couple other things to do. How long is KO? How long is KL? And how long is MO? Right? Interesting. That's going to be really hard to do, given that I have no dimensions here. So here we go. Let's throw in a number, all right? Let's make it something easy. Let's say if KO, I don't know how you're going to do this problem without any dimensions. You know what? You can skip that. How about that? Merry Christmas. You don't have to do the last three problems because we don't have any side dimensions to throw in there. So there we go. If that makes sense, if you're able to do those problems, then hey, you're ready to do any of the homework.